Hello student, welcome to my channel Concept Clear by Maji. Today in this video I will discuss with you gravitation, universal law of gravitation. This session will be very interesting. After this session, I hope you have no doubt about in this chapter. But it is not possible to clear the entire chapter. So today I will discuss about only universal law of gravitation and gravity. I will clear your doubt about gravitation and gravity. Okay. First of all, Newton's universal law of gravitation. Any two bodies in the universe attract each other with a force, and this force is directly proportional to the product of their masses and inversely proportional to the square of their distances. You have to learn this law with commas and full stops. Okay, this is Newton's laws of motion. This is not yours or mine. Now explain this law. Any two body in the universe. Universe means no. In universe, Earth is a very small object. Moon is a very small object in the universe. Any two bodies in the universe attract each other. A and B, these are two objects, attract each other with a force, and this force is directly proportional to their masses, product of their masses. Suppose A is a body, its mass is m1, and B is another body in the universe whose mass is m2. The product of their masses m1 and m2. According to Newton's universal law of gravitation, force which is acting between these two bodies to attract each other, this force F is directly proportional to the product of their masses. If the product of mass increases, then this force will also increases. If the product of their mass is decreases, then this force will also decreases. And it is inversely proportional to the square of their distances. Suppose square of their distances. First of all, distance. Distance means end of this and end of this is not distance. Distance from center to center distance. Distance is considered as center to center distance. If the center to center distance between two bodies is r, then according to Newton's universal law of gravitation, F varies 1 by r square. Now, mathematical expression. According to Newton's first law of motion, F varies m1 m2 and F varies 1 by r square. Combining these two from 1 and 2, F varies m1 m2 by r square. Variance converted to is equal to, then a constant g, F equal to g into m1 m2 by r square. This g is called gravitational constant. Therefore, g is equal to F into r square by m1 m2. It has a constant value 6.7 into 10 to the power minus 11. And its SI unit is Newton force, Newton r square, meter square by kg into kg means kg square. So kg to the power minus 2. This is the SI unit of universe constant. gravitational constant. So what is gravity? This is gravitation. F is equal to gravitational force. According to Newton's universal law of gravitation, two bodies in the universe attract each other. Among between these two bodies, if one of them is the earth and a pen is the another object, then the force acting between the pen and the earth is called gravity. Gravity is a special case of gravitational force. Gravity is a special case of gravitational force. That means in case of gravity, this is earth and this is another object. The distance between the radius of the earth is r. In considering radius r and distance from the surface of the earth to this is negligible. That is why this force, that means gravity, is equal to G m by r square, which is also called weight, m into g. This is the force by which earth attracts a body towards its center. Therefore, mg is equal to g m by r square. Small capital M cancelled. Therefore, small g is equal to capital G into m, small g. M into g means small g, small m. Therefore, g is equal to capital M means mass of the earth divided by r square. This is the relation between small g and capital G. I will give some ideas in case of falling body and rising body. You have already know about the equation of motions. These are on plane surfaces, but this will be converted into falling body and rising body. These will help you to solve the problems related to gravitation in case of falling body and rising body. All three equations, motion in one dimension, chapter 1, motion in one dimension. V is equal to u plus at. Number 2, S is equal to ut plus half at square, and number 3, V square is equal to u square plus twice as. These equations in case of falling body or rising body will be converted. Falling body, and this is rising body. Falling body, in case of falling body, this equation will convert it to V is equal to u plus gt. S converted to h, height, h is equal to ut plus half a t square. A means g, gt square, and V square is equal to U square plus twice GH. These are the converted form of the equation in one dimensions. In a case of falling body, all will be plus, but in case of rising body, V is equal to U minus GT, H is equal to UT minus half GT square, and V square is equal to U square minus twice GH. Now, what will be the maximum height of a body and what subjects it is depend? If a body is thrown upward, then let maximum height be h. Therefore, V square is equal to U square in case of rising body minus U square minus twice GH. Therefore, at the maximum height, V will be 0. U square minus twice G into H. Therefore, H is equal to U square by 2G. This is the maximum height it can go up. That is the maximum height. You directly find this maximum height if initial velocity of the body and acceleration due to gravity 9.8, approximately 10. Okay. Next video I will solve some problems related to this chapter and clear the ideas of the numericals. Okay. Now please subscribe this channel and share with your friends and like it. Okay. Thank you.